And today we're going to be learning microbit, MakeCode, specifically coding. But we're also going to talk about coding in general and some of the benefits of coding in learning in classroom, and some of the activities that we can do in a classroom as well. I really encourage you, when we get in the hands-on, to ask as many questions as possible, to try, and I encourage you also to share any ideas that you have from your experiences from coding and also using microbit if you have those experiences. So I'm just going to continue on, and I do, this is our STEAM 3D lab, which is where we work at the Ontario Tech University Faculty of Ed. And I think I mentioned we do have our fearless leader here, Dr. Jeanette Hughes, who's the Canada Research Chair, and I'm going to hand it over to her to say hello, if that's all right, because she's here.
Hi, everyone. I won't put my camera on because I've just gotten out of the shower because I had to make a foray out into the world, and so I wouldn't say I'm particularly fearless right now. Kind of paranoid about getting sick, but I hope everyone's keeping well, and I am very happy to welcome you to this session. All I want to say is that we have gotten some funding from the Mass Knowledge Network to run additional sessions, and we're going to be running 3 kinds of sessions every week for the next 8 to 12 weeks, depending on how long schools are closed. And sessions will vary in terms of content and in terms of audience. And one of the things that we're doing, which is a bit of an experiment, not sure how it'll go, is we are asking teachers to sign up to bring their class in, and we would work directly with your students. So just watch for that on our social media channels. We are on Twitter, we're on Facebook, and we're on LinkedIn. And certainly would love to be able to work with you and your students beyond this session. And I won't be staying for the whole session, so you are in terrific hands. You can't get better facilitators than Margie and Jen. So I'll just turn it back to them. Have fun.
Thanks, Jeanette. Geez, no pressure. No, I'm just kidding. This is a smaller group, so I feel pretty good in terms of the session. I will mention that when you are conducting an online session, there's lots of little tips and tricks, and I think I mentioned that there was previous sessions that we had. Laura Morrison, who is here, I believe I saw her name. Is that correct? She actually led those. She is our lab manager.
Hello.
So welcome, Laura. If you could just introduce yourself.
Hi. Sure. So I help run the research lab. I'm currently located in Hawaii, so I do a lot of managing remotely and and teaching. So that's about it.
So thanks, Laura. And then we also have Jennifer Robb, who is a research assistant at the STEAM 3D lab. Jen, you want to introduce yourself?
Yeah, sure. So yeah, I also work at the STEAM 3D Maker Lab. I help do a lot of the kind of day-to-day management stuff that needs to be done physically in the lab, since Laura is located in Hawaii at the moment. But yeah, I do a lot of the same sort of facilitating, research. I'm finished my graduate courses now, so I'm head on into writing a thesis. So we do all sorts of fun stuff.
Thanks, Jen. And these ladies are really amazing. I've learned so much from them personally. I am getting my master's right now. I'm currently in my thesis courses and working on my thesis. And I'm also a teacher. So I teach intermediate secondary. I teach chemistry and biology. But I would say one of the things from the lab is I've learned so much about technology and effective ways to integrate, and also online learning now. So this is us. This is our web page. And so if you want to click and get any more information, also if you want to see any previous online sessions, you can just click on this slide. One thing I wanted to mention, actually, I'm just going to go back for 1 second. This bit.ly right there, maybe I can ask Jen to post that bit.ly. This is our slides. So I encourage you to either click on this link or if it's posted in the comments, you can just go in and click on, there it is, right at the top, the link for the slides. So continuing on, just who we are, we've already talked about icebreaker. I have already asked a lot of you. I might just ask Katina in a second just to hop on in 1 minute, but I do want to know exactly some of the things that you want to get out of the session today. So that will be part of the icebreaker. Then I'm going to go into why code and what is MakeCode. And we'll get into our break. It's called breakout groups, but because we have a small session, we're all just going to stay in one session and we're going to learn together. And then we're going to have a group discussion on strategies for teaching coding and learning activities. And finally, a summer, like a debrief. But I always like to start off with why learn to code. And I think that this is just a very important thing to always revisit. We have done a lot of sessions in school. And one of the things that I've noticed is there sometimes is some hesitation. Why do students even need to learn? It's play, etc. And not everyone, but there is some resistance. And I feel like there's one of the biggest reasons for me, not only is it that it helps you think and helps you create, but if we think about some of the future jobs that are going to be available and in the not so near future, I think about Internet of Things. I mean, how many of you have smart devices in your home or have heard about smart devices? You can just say yes or no in the chat box. Yep. 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 I mean, I think we're all starting to hear, yeah, I have Google Home. I mean, basically my everything, my thermostat, my security system, it's all integrated with my smart home right now, my calendar. Shortly, I'm going to have it integrated with my TVs. So literally it could all work by voice commands. So a lot of this, and then hopefully start getting even more connected. And that's really about Internet of Things. And when we start thinking about it and how big this can grow to smart cities and smart traffic, who's going to design these things? Who's going to code it and design it and create it? That's a future job. That's a lot of it is not even quite there yet. So we have to prepare our students for these kind of skills. And a lot of also careers are asking that you have some coding experience. My husband works for Deloitte. He's in working in the financial sector, and they actually want them to have some coding experience. And yet coding is not necessarily defined in their job description. So understanding these skill sets and learning to code is becoming a fundamental skill that I think a lot of students need to start developing. And it also teaches them collaboration and perseverance and creation, and they can create and innovate. What I find right now, and I have two children, one is in grade 5 and the other is in kindergarten. And I find also with a lot of young students is that they're very good at using technology. They can pick up an app and use it. But creating with technology, creating an app, creating games, I don't see it as much. And I feel that that kind of skill needs to be developed, the creation with technology versus just purely using technology. So those are just some of the reasons. And Andrew says, was there a question? Do you have any virtual opportunities? I'm based in Ottawa. Is this for, I think this is a question that Jen put up. Maybe Andrew, could you explain? Or
yeah, I think he was responding to when I was just telling the OTU students that if they want to drop by or check out our volunteering internship opportunities. I believe it was in response to that.
Okay, sorry. Just wanted to make sure I wasn't missing that. But that is pretty much some of the reasons why I have seen and learned and what I've spoken to and why I think you need to learn to code. Any other thoughts from any of you of why you think students need to learn to code? Not to put you on the spot or anything. We'll move to the next slide, but if you think about that, let me know. So Katina says critical thinking and problem solving, absolutely. Encouraging creativity, absolutely. Those are just some of the things I've seen when we've done coding or creating with some sort of app that requires the coding involved. English and French, a method of communicating. Yes. Digital literacy, absolutely. So why learn to block code then? If we're learning to code, why block code? And I guess my first question to each of you is, how many of you have experience with block coding particularly? You just say yes or no. Yep. 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 So then my second question to you is, how many of you have experience with syntax, sort of anything that's like a written language, syntax, Java, C+, those kind of things? Can you say yes or no? Nope, nope, nope. And that's what I find a lot of people don't have that experience. Some do, Jen does, and Andrew does. But I would say for a lot of younger people in particular, as they're learning through, they learn it at senior levels in high school. And what we start off with is block coding. And the reason block coding seems to be, and what I've noticed why it's a good place to start, is because it's really easy to use. It's color coded. Every single platform I've used that's block coded, that involves block coding, is color coded. It looks like puzzle pieces that snap together, easy to follow. So typically, that is why we encourage block coding, particularly, I would say, at the elementary level. That is not to say not to encourage them to start learning some syntax, but learning syntax is like learning another vocabulary, in my opinion. So block coding seems to be an easier place to start. And there's lots of free platforms right now, and a lot of creative things that you can do. And one of the other things we mentioned is low floor and high ceiling. So if you have even a little bit of experience or no experience, you can come in and start creating with block coding. But if you have a lot of experience, you can still do a lot of things with block coding. So it does allow for those different levels of experience and learning and understanding. So what is MakeCode? So I guess I'm going to ask any of you if you know if you have seen or used MakeCode. And you can just say yes or no. Yes. Yes. Nope. Nope. Yes. Okay, so there's a little bit of a split here. So MakeCode is developed by Microsoft, and it is a free online coding platform for creating engaging learning experiences. But there are three aspects to MakeCode. And one is the block coding interface here. So you can see the middle part, it allows for block coding. What I think is fantastic about MakeCode is the second part here, which is it has a simulator. So a lot of the MakeCode interface itself has a simulator. MakeCode works with various different technologies, and I'm going to show you that on the next page. Majority of them have a simulator of some kind. So why is a simulator good? Well, it's an ability for you to see whether your code will actually work. So you can put in a code and see if it's going to work the way you hope it will work. So it's a really good way to demonstrate before you start uploading it onto something like a microbit, which we'll talk about in a minute. So MakeCode is really the coding platform, and it has a simulator, and then it also has this other part, which is a JavaScript editor. So what that means is that whatever you code, block code, you can then see it in Java. So I'm just going to show you just quickly what that might look like. So this is MakeCode microbit. And as you can see here, here's the block coding interface. So it's all block coded. I can choose my blocks here. Here is the simulator on the left. And on my right, or on the top right here, you can see the JavaScript. So whatever I've created in the block code then gets translated into Java. So it's a very interesting interface in the sense that it is slightly different than maybe Scratch or other block coding interfaces you might have used. MakeCode, I mentioned, doesn't just work with one technology. It works with a few. So as I mentioned, MakeCode is actually the coding platform. It's the place that you give instructions. But it actually works with Microbit. It works with this other it's Adafruit, which is a Circuit Playground Express, which is, I would say it's very similar to Microbit in the sense that it allows multiple connections, but it doesn't have an LED the same as Microbit, an LED screen. And then there's Minecraft. So if any of you are familiar with Minecraft, a lot of times it's been drag and drop. You can build things in there. But with MakeCode Minecraft, you can actually code and import that code into Minecraft, excuse me. There's also Lego Mindstorms. This one is Q, which is a robot. And then there's an arcade. So one of the things I wanted to let you know about my slide is if you see something underlined like here, you can actually click on this and it will bring you into that page so you can see further. And I would encourage you at some point, we're probably not going to go through it today, but I would encourage you to take a look. And like if you look at the arcade, you can actually see how that actually looks like, the interface. So I'm not going to go through it right now, but if we do have time at the end, you can try out these different MakeCodes. We are going to focus on Microbit today, but as you can see, the interfaces are very similar. There are some differences in text style and the simulator, but most of it becomes very similar as you start working through it. So MakeCode is the coding platform, and it can work with various different, and these are hands-on technologies. And I always like to have this available for educators, which we have a lot more of, or a lot of people here are actual teachers or have some sort of education focus. There are always a lot of resources for coding, but if you actually go to MakeCode, they have specific pages for educators. So clicking on this link, you can actually see the resources, MakeCode in the classroom, and you can go through here. So this is a resource for you to take, and if you're looking for ideas, this is another place to explore and see what others have done. So now I mentioned we're going to specifically focus on MakeCode with Microbit. So MakeCode, again, is that coding platform, and that's where we're going to code in, but we're really looking at how it works with Microbit. So I want to give you a little introduction, and we'll watch this video. One thing I did want to mention when you are doing, as I'm waiting for people to hit done, when you're doing online learning, it becomes important to try and manage the chat. So two things that can always help you when you're doing online learning is, number one, if you have a class, if you have two teachers in the class, one can monitor, or sometimes you can have a lead student that monitors the chat. And you'll see my face is sorted to the side, so I do apologize about that, but a lot of times it's because I'm looking at the chat to see. So everyone has seen the video. So that is Microbit. It is just a quick overview. It has been, it's been created by BBC, I believe, which is the same news BBC that we know of. And what it is it's like a mini computer, and it has some processing capabilities. It has on the front of it here, you can see there is, I believe it's 25 LEDs, and it has 25 LED lights. It has 2 buttons that can be programmed on the front, and then it has all these pin connectors. And then right here is where you would actually plug it in through a USB connector to your computer to upload the MakeCode. What I love about Microbit is the fact that it has it's not just a little computer, but it also has onboard sensors. So it has a light sensor. So not only does it display things on the LEDs, so you here it's showing a smile, but you could display numbers and words that would scan across the screen. But it also detects light. So it can function by telling you how bright a room is or how dim it is. Also on the back, it has a compass and an accelerometer, and these two are an accelerometer is a motion detector, and we're going to program something today. And so where can you get a microbit, and are they expensive? So Andrew says they're around 20. I think our amount was $23, if I'm correct. There's different places you can get it. Amazon, you can go to, so it's very cheap. And I think you can buy in a bulk too to get it a little bit cheaper. So if you go to Google, you can buy, I think, a pack of 10. And I think it's something like $200. I'm not entirely sure, but there's some links here that Jen has posted. And I believe it's around, he said 20, about 20. I think we paid 23, if I'm not mistaken. So from a perspective of use, 24, thanks, Laura. From a perspective in education, like from a resource for teachers, it is very inexpensive in comparison to something like an Arduino or Raspberry Pi, some similar devices, and I find it easier to use. The other thing, so I mentioned there's these onboard sensors. So that allows you to detect things from the environment. So the accelerometer is motion. You can see here that there's also a temperature sensor on here. So you can detect the temperature of the room. You can also have what they have here, which is a radio and Bluetooth antenna. So what that does is, with the radio function, it can have two microbits communicate together. So you can send secret messages from one to the other, or collect information from one to the other. And the other thing with the Bluetooth is you could actually, there's some apps that can control your microbit. So I think in the video you saw someone taking a picture with their phone, and they clicked the A button, and that was through Bluetooth connectivity. So there's a lot of functionality here, not just as a processor, because the moment that you have a processor, you can build robots, right? Like the ability to build things becomes immense. So the creation idea is huge, but also the ability to sense. So now you have these sensors. Now you can start collecting data from the environment. So you could start creating smart gardens. You could do motion detectors in the room. There's so many different things that you can create at that point. So it is just the microbit alone. And then because of these pins and these connectors, you can then connect to other external sensors, which allow you to even detect even more. So we've used moisture sensors, touch sensors, etc., and all controlled through the microbit. So very interesting, and I think very dynamic technology to use. Step counter, Nadia said, absolutely. In fact, we could do a step counter. We could code it today. So let's continue on. I just wanted to show you, for Microbit for Educators, what they have now is a Microbit classroom. So if you click on this, you could actually set up your own classroom. Now, I didn't do this for today, and the main reason is because the way that it's in beta version. Sorry, my computer's a little slow. But it also is, the way that they encourage you to teach a class isn't probably the best for the purposes of what we're doing. But you could absolutely set up a class here and put in the name, and you could make it MakeCode or Python, and you can launch a classroom. So this is actually I think a relatively new. I mean, if I think about it, a couple months, I'd say around 6 months ago, that was not there, I don't believe. The other thing about Microbit is it was provided to, I think, all of the, I don't know if it was grade 6 students, or 3 students. I can't remember which grade, but every single I'm going to assume grade 6 UK students, grade 7, thanks, grade 7 UK students it was provided to. So the amount of material out there that teachers have, lessons, activities, etc., are immense. And here's just one link in the microbit to those lessons. And it breaks it down, provides details about how you can do the lesson, etc. So one thing about the microbit is we sort of say, I talked about that low floor and high ceiling. So why can microbit do that? And really it's because it has this low floor. So very beginners can come in and start using it with the block coding. There's a lot of intro tutorials. You can start with a flashing heart. So we're going to actually start with that today. And then you can do mid-entry, which is block coding. And I like to say with a little bit of logic. So now you're moving up a bit. You might add if and then, or if else. You might add using some of the sensors. And again, there's lots of lessons and tutorials to help you with this, and information. You can just Google and you can find so many different lessons here. And then finally, the high ceiling, I mentioned Java here in the mid. I mentioned that the block coding, there's also the Java, but there's also another coding platform, which is, it's Python based. It's a MicroPython based coding language. And I believe, not to point you out, Nadia, but I showed you how to do a code for a temperature sensor with the Python. And so there's lots of coding that you can do, and with the Python, you can really bring it up even more in terms of its processing and ability, power. So, and this was just a look of what the classroom would look like, the microbit classroom. I took a screenshot. So you can complete code setup, you can share the details, you can view students' work live, and then you can save the classroom file. So really helpful when you're doing that. How many of you have used Scratch? If you could say yes or no. Yes. Nope. Okay. For those of you that have used Scratch, have you ever created a Scratch classroom? No. No. Okay. So one of the things you might want to endeavor, just like in microbit here, is, really sort of as educators, they have these in some of these coding platforms like microbit and also Scratch. They have these classrooms. So it really allows you to use it with a class and to see their work. That's really, really beneficial when you're trying to help troubleshoot, or you're trying to help them if you want to assess some of their material, et cetera, et cetera. So learning, this is a resource for you to take a look at to test out the microbit classroom. So right now we're going to go into our hands-on part. So the first thing I'm going to do is we're going to do an overview of MakeCode for microbit. And we're going to go through a little bit of some introductory ways of learning microbit. And then what we're going to do is we're going to walk through creating a code together, one a little bit more complex. And it's rock, paper, scissors. We're not going to use the tutorial, but we're going to talk about it and we're going to create that code together. And then I'm going to have you explore and just try different things. You can try tutorials or just try different codes. And then as you're exploring, any questions you have, we'll go through those. And then finally, we're going to end with a demonstration of the compass functionality. Now, I don't have a microbit here. A lot of the technologies, like the hands-on technologies, are in our lab, but we're lucky today. Jennifer does have one. Also, Laura, I think she's still here. She has one as well. But Jennifer has set up the compass, so she'll be able to demonstrate it for us afterwards. Thanks, Jen. Okay, so to get into microbit, I've created a quick link so that we could all just go in right away. So I'll just leave this up, and if you could just let me know that we're going to go right in now, and we're going to start coding in. Thank you. Yeah, if you could let me know if you're in, because I'm going to click on this link and I'm going to come off the slide in a second. Okay. Okay. So I think most of us are in. If anyone's having some issues, again, it's makecode.microbit.org. There we go. So I'm just going to click on that link, and then you're brought here, which is in the MakeCode first page. As you see this, you're not in the coding interface yet, but every time I go in, it actually it remembers me in this particular case, because I actually haven't signed in, but it remembers me from the computer that I was on. So so if you do go to a different computer, I know there's a way you can actually sign in through your Microsoft as well, your Microsoft account, and then you can save all of your projects going forward. You could also download them as well. On the main page, there's my projects. This one would be creating a new one. I just want to show you, if you go down, I mentioned there's tutorials. So there's flashing heart, there's the name, there's smiley buttons. It's saved in the Chrome browser, yeah. And then there's live coding. So different examples: games, radio games, fashion. I think someone mentioned the step counter, so that's an option here. And they really are really easy to use videos to show you how to create. And you can see all these ideas: soil moisture, for example. This is a good one because it doesn't even use a moisture sensor. It purely uses nails. So it's basically, you could use silver spoons. Silver is very conductive, and you could use that in terms of measuring the current and seeing how much moisture is in a plant. So lots of different ideas here. But we're going to start and take a look at the interface. So if everybody could click on a new project. Class, yeah. So yeah, as Jen mentioned, Andrew, it saves in your browser. But again, if you do go to a different computer, like I have multiple computers open, you won't see the same project. So the only way I can see it on different computers is I actually sign in on my Microsoft account, and I actually can see it. So here is our interface. So the MakeCode interface, if you remember, there is the block coding, which is right in the middle. And here's our menu options for the block codes. And then you have your simulator on your left. And if you have any interest, the JavaScript is on the right. So immediately when you get into Microbit, it immediately starts with on start or forever. And so let's, for our first code, we'll walk through and we're going to create a name, or we'll have our flashing name, and we'll have some sort of symbol with that. So if I do that, and follow along, and if you have any issues, let me know. But we'll move the on start over. I'm going to do this so that it's forever flashing. And in this case, the menu options, I want to look at the basics. So the basics, you'll see here, I can show a number. So this is very good when I want to display. I'm going to do this in a minute when we display temperature, for example. Temperature, we want it to show as a number. And so this would be one way we would use this. You can show LEDs. So you could create your own symbol, or if there's specific pattern that you want to display, you could pull this over. You can show an icon. So I want to do a word. So if I want a string of words together, they call that a string. So that's for any wording versus numbers. So I'm going to encourage you to put on show string. Now, right now, it says hello. So you can see on the left, it's flashing hello. But we can change that to say, instead of hello, we can say Margie. It's my name. Now I also want to put maybe a little symbol here. So I'm going to put a little icon here that was also in BASIC. And if I click down, I could choose any of the different symbols, but I could have also created my own if I wanted to just show I could have pulled over the show LED and just created my own as well. But I'm going to use one that already exists, and I'll do this little car. So then you can look on the left-hand side, and I can see my name flashing, and I can see a symbol. So was everybody able to sort of do that, that code on their own? Yes. Yes, awesome. Yes. Okay, so we have now, you know, that's a pretty simple basic code. We basically are showing our name and showing a symbol. But I want to explore now a few more of these options. So if you look under basic, you can see also that there's a pause. I do encourage you to sometimes use a pause. I use it when I want to hold on. I don't want it to, I have a couple things that I'm flipping it through. Like, so for example, I don't want it to go through so quickly into one and the other. I want it to show Margie, wait a second, and then go to the symbol. And you can change the amount of time it waits here. Going back into basic, there's more here, which you could clear your screen and then show arrow north, which is just a direction. So the other options are input here. So I mentioned there's button A, button B, etc. So what we can do here is we can say, let's pull over on button A. And what we're going to do is we're going to test the temperature. So what is the temperature of the room? So if you pull over button A and it says, or on button A pressed, and what we want to do is, because we're looking for one of the sensor inputs, we actually have to go to input. And in the input menu, you can see here, there's on shake. So this applies to an accelerometer, so motion, the motion sensor. You can see when a pin is pressed. So that is when you have the additional pins at the bottom here. So maybe you connect something else to it. Or, you know, it's a touch sensor. So as soon as you touch pin O, something happens. And then we have these options here. So you can see the acceleration, light level, compass reading, temperature. So I want to read the temperature of the room. So we want the temperature pulled over here. But when you look at it, the temperature right now is grayed out. So I need something that's going to show me the temperature of the room, which is the number. So where do you think I need to go? If someone could tell me, I think I showed you before, if I need to show a number, does anyone remember where I need to go there? You can either go on the mic or to basic and show number. Perfect. Basic and show number. So I just go in here, I pull up and input the show number. I click in here and I have input the temperature. But as you notice, it's not displaying on the left-hand side. And the reason why is because it's only going to work the moment that I press the A button. So on my simulator, I have to press the A, and immediately you can see it'll show 21. Now, on your simulator, you'll notice I can move this bar. So if I move it up, then the temperature that will display will be higher. Okay, if I press A, it should show 41. So you can play with your temperatures. This is a good way to test to make sure that it is actually demonstrating. Was everybody able to play with your simulator and try the different temperatures and show it? Yeah. So again, another one that's a little bit not so difficult, pretty clear ways to do that. If I wanted to show the light sensitivity, so let's say I want to, again, the light sensitivity is a number, but you could also show it in a bar graph as well. My temp is 21. So I think your temp will default and you can change it on your simulator. So if you actually had a microbit in your hand, you could pull it out. Once you've uploaded your code, you could actually test it. You could put it into something cold, or you can hold it and keep it warm, blow on it, make it warmer, and you can test the different temperatures. So going through, I want you to discover a little bit. I'm just going to talk a bit about the menu options, and I want you to play around, and then I'm going to give you a couple minutes to play around, and you can ask any questions as you go, and then we're going to create a code, a little more complex code together. Just to let you know, the music option. So this, if you want to play a tune, for example, let's say I put this, and it immediately shows you actually have to connect it. You would actually have to connect it to some sort of device, like something that could actually play a tune, like a microphone or some sort of speaker. It would be a speaker in this case, if you wanted to play some sort of music. So you do need to connect. LEDs. So an LED is how it, you can plot things like an X and Y, or you can plot it like a bar graph. So what I have done is I've actually used this for the light sensitivity. So I've shown a number, but I've also shown it displaying not just as a number, but also as a bar graph. So I'll show you how I do that as well. So in this case, we don't want to see the temperature. What we're going to look for is the light's level. So again, in this case, I'm pressing it, and if I press the A button, you see on the simulator here, it has 128, which means it's sort of midway lit. If it's fully lit, it's 246. But that may not mean as much to you. So what you can do here is you can plot the graph of the light level. And I usually have to put it up to 255. And I can put my light level here. So right now it's midway. If I want to see, you can see that it's midway lit, and midway of the bars are showing. If I make it really bright, almost all the bars are showing. So another way to visualize it versus just seeing a number. Were you all able to sort of see that difference there? So it's a good way to actually use your LEDs to display something very quickly. Just going on the side, you can see there's radio. I mentioned radio is one way you can have two of the microbits connect together. You can have loops, which is you want something repeating, or you want, while something is happening, do this. And then we have logic. So if something happens, then this should happen. If then else statements, you have comparisons here, and then variables. And finally, math. So a lot of different math functions, pick random numbers. And there's advanced. So we're not going to go into the advanced here, but there's a lot of different advanced options here, more functions, arrays, text. So lots of different ones here. There's also, I've used Inksmith. The Inksmith has a climate action kit. So I have used their climate action kit, and they have additional sensors here or different options here on the menu for moisture sensor readings, touch sensor readings, etc. So I'm going to let you play around a bit. I'm going to give you around 10 minutes to play. I want you to ask questions as you're going through, and then I'm going to come together, and I want us to go through and create a code of a game, rock, paper, scissors. Don't look at the tutorial. I ask that you don't look, because we're going to walk through the code together. But in the meantime, I want you to just try out some different things. So after 10 minutes, I'm going to call you back in. Is that okay for everybody? Because I really test this out and see if you can try out the simulator. So Jenny has a question of what sort of conditionals. So I'm these ones there. I'm glad you asked that. When we come back and we're going to do the game, that is actually where you might use it. But you can also see that I did it here. And let me explain, Jenny, why I did a conditional here. So you can see I actually put the condition here, if button A pressed. You may remember I actually had another. I had it when on button A was pressed, and I had it like this, right? So that's actually how my code looked. The problem with that is, you see when I'm pressing A, it's actually not able to show it. And the reason why is because I have this forever loop that's happening here that's saying on forever, show me the barcode and the light level. And then I'm saying, well, button A pressed, show me the light level, and it's sort of conflicting. So it's saying, oh wait, I got to show the bar graph, but I need to show the light level, and it just sort of sticks on the bar graph. So instead of saying on button A pressed, I actually in this case would use a conditional. So I'd say, here's the bar graph, but if I press button A, then can you show me the number? Else, just go to the bar graph. You see how that works together. So instead of having it on the button A press, which was causing a conflict, it wasn't actually showing me the light level, I used a conditional in this case. And then when I press play, I can see the bar graph here, but then I press A and I can see the level. So that's one sort of reason why. You know, I think about ifs in terms of computers are not intelligent. They have no brains. Let's take out artificial intelligence right now. So basically, you've got to tell your computer everything to do. So if you have a robot, for example, and it hits a wall, you've got to tell it what to do. It's not going to know what to do. You've got to tell it to stop and move and go. If you want it to display something when it's pressing a button, that could be an if condition as well, because in this case, we want it to be able to do both. We want it to show on a bar graph. However, if a button is pressed, then we want it to display a number. So that's thinking about those if conditions is really about thinking about if I need to do something, if it needs to do a particular action, I really have to tell it to do that. And if I want it to do another action, that might be an if statement. That's an example. Hopefully that explained it a little bit, Jenny. So wait, so they're working together versus two competing instructions. Exactly. And at first, when I put the two instructions together, sorry, Jen. When I put them together, they were competing, and now they're actually working together. So wondering how everyone's coming along. I'm going to start. If it's all right, can I ask everybody to come back, and we're going to create the game rock, paper, scissors together. No looking at tutorials, okay? Is everyone okay with that? Just say yes if you're good. Okay. All right. So I need you to help me. We're going to create a game. And the game is rock, paper, scissors. How many of you know? I'm assuming most of you know rock, paper, scissors. You know, when we shake our fist 3 times, 1, 2, 3, on the 3rd time, we either randomly choose a scissors or a paper or a rock. And rock trumps scissors, scissors trumps paper, and paper trumps rock. So that's the gist of the game. So we're using motion. So the first thing that I'm going to look at, and I'm going to ask you is, I'm going to say the hint is we need to do an input. So we're saying when we're using motion, or it's whatever kind of motion you can call it, or shaking, we need it to do a certain thing. So what would I select here of my options? And you can hop on the month on shake. Yeah. So this is like if you're using the motion detector on here, so you can see up here this shake. I haven't got anything in there, but you can see that that is on the simulator now. Okay, so we got the motion detector there, but we need to be able to demonstrate on the LED screen some sort of symbol for rock, paper, or scissors. So what will we use to actually create our own image of, let's say, rock? What would you go to? Show LEDs. Yes, we'll come to variables in a second. You got it, Nadia. You're thinking ahead. Good job. So we're going to show an LED first, okay? But let's say here, I'm just going to type it in here. We have 3 options, right? So the first one I'm going to do is, let's do scissors. How do we want scissors to look like? Let's go like this, like that. And you can do your own scissors. That's my scissors. So scissors is 1, but we need another 2, right? Because we need one for rock, paper, and scissors. Okay. And then I'm going to do last one for paper. But all I'm really doing right now is just showing 3 different screens. So it's not really a game yet. I have to shake it and it's showing all 3. But I need it to be able to show it. It needs to choose. It needs to be able to choose randomly one of these objects. So if I need to randomly choose an object, where would I go? I need a random number. I need a random number between, we're going to have to assign these LEDs a number. We're going to have to say, okay, if it's 1, it's going to be scissors. If it's 2, it's going to be a rock. And if it's 3, it's going to be paper. Math, right? Pick a random number between 0. We want to do it from 1 to 3. But you can see that it's grayed out. So right now, we need a place for that random number to go. So we need to create some sort of holder for the number to go, for the random number that gets chosen. So coming back, where do you think that, have you ever heard of a variable? You'd say yes or no. Yes, Jennifer has pick random. Yes, okay. So yes, so variables, so when a number varies, when you need a number coming in and that number can vary, this is just an example when you use a variable. When you're asking for a number or some number is getting pulled in, such as from even from some of the sensors, and you want to track that, and it keeps on changing, for example, that's one example of when you would use a variable. So in this case, we can call this the hand. The hand. So we want to say our variable becomes set hand to pick a random number between 1 and 3. But what we need to do now is it's still not giving me we need to input a condition. We need to put something, something as a condition, so that if it picks 1, then it will show scissors. If it chooses rock, then it will, or if it chooses 2, then it will be a rock. Else, if it chooses 3, then it will be the paper. So where do you think we would go for now, going back into what we talked about a little bit earlier, which was those conditionals? If true, then yes. So that is in our logic. So if we go here and we say, well, and we have to put it right up, I put it under here. And I actually got to slide this out for a second. And I'm going to slide that one out. So, but now I have some sort of, it just says if true, then this. But we need some sort of, now we need to sort of say if number 1 is chosen, which is number 1 will be our scissors. If number 1, or if the value that is randomly chosen in hand is equal to number 1, then it should be scissors. So where would I have some sort of comparison? Where do you think I should go to get? And also look at your hints. If you have something like this where it says true, then this shape can be replaced by something. So sometimes it's about looking where you think that shape will be. So does anybody, we want to compare 2 things right now. We want to compare if the value that is randomly chosen here, and that goes into our variable, if that equals to, let's say 1, then it has to, yes. So it's a comparison. So we go into where's our comparisons in our logic? Sorry, comparisons in logic. And what do you notice about the shape right away? You can see that these shapes sort of line up exactly. So we want to pull this up. Now it says if 0 is equal to 0. Well, we want to say we need our variable, right? Because that number that's chosen randomly, so the hand chooses 1, 2, it's choosing some sort of number. Sorry, it's 2 fingers. So if the hand has randomly chosen, so we need to go back to our variable and we need to say the hand, and we got to get it in the right spot here. So if the hand is equal to, and we've chosen pick 1 to 3. So what number do we want for, I'm going to say 1, okay? If the hand is equal to 1, then it'll be scissors. But if you noticed here, I got 2 more options. If I just say else, then it's not distinguishing between 2 and 3. So in order to distinguish between 2 and 3, I need to click on this, sorry. But it's still not telling me, it's still not giving me the option for which one will be 2 and which one will be 3. So I actually put in myself the second condition here, I think. Whoop. Because right now, all it's saying to me is, if I go and if the hand is here is 1, then it's this. But what happens if it's 2 or 3? So we need to have another if statement here. So, and I'm going to pull that one out. And I'm sure there's other ways that you could probably do this too, but I'm going to show you this one. So else, if, and I just put in my same condition again. So I would go back into my logic, I'd go back into the conditions, and I would say in this case, it's no longer about the hand being equal to 1, it's saying if the hand is equal to 2. And now we don't need another option here because, oh, I saw something. Or you can click the plus for another option in the statement. There we go. There we go. Sorry. When I clicked it first. So instead of, sorry, pulling it out like this, let me change that. There, sorry. You have to actually click the plus to get that in. I knew it was missing something. So did you see that? If you click a second plus, then you can get the if the hand is equal to 2. So you see now I have if the hand is equal to 1, and else if the hand is equal to 2. And then finally, we don't need to say 3, right? Because it knows that this is the case here. I think I can actually just go like that. So now let's test this out. I think I have this right. So we've got our on shake. Yeah, so as Jen was saying, there's multiple ways that you can do code. This is actually better than the first way I was doing it. You just have to press this plus sign twice to get it. But if you look here, you got if the hand is equal to 1. So our variable is hand. I have a math condition of picking a random number from 1 to 3. I say if the hand is equal to 1, then it'll show scissors. If it chooses number 2, then it's going to show paper. And the last option is else it'll be here, which because there's only one more option, you don't have to specify it. So is everyone following along why you would use a variable, picking the random number, and the if then else? And I want to make sure, was everybody able to input this code? So as Andrew and Jen are mentioning is that one of the things you're going to find as you're doing code, and I think I do this a lot, which is the first time I do the code, I do it probably the longest way and then the most steps. And as I learned more code and as I try it, you can actually learn how to simplify. But let's try and play rock, paper, scissors. It's hard to do when you can only see my screen. But you could actually play it against the machine. So I'm going to try and play it against the machine here. And you can actually like shake it or like press the shake here. So let's just test it. Okay. What you want to do is when you do press this shake, so it is actually going. So if you see something like that, something is happening to your code. So let's shake it. So it doesn't like my thing. I'm gonna have to put it in here. Let me shake it. There we go. So I had my if you notice, I had it in the wrong place. If you have something in the code in the wrong place, it will give you the error that it gave me right there. It executes in order. Okay, so let's test it out here. So I shake it and I got, this is in my paper. This is scissors, and that's rock. Number, it's interesting that it's doing that in that order. So you can see sometimes it's going to do multiple in the same. but it should ideally, if you shake it, it should do various different ones. If you're finding that it's repeating the same one over and over, just double check where certain of your code or your block code is placed. Now, there is a tutorial that you can walk through that can help you through these things. But I think one of the reasons I wanted to show you this is because you can actually think through some of the logic and also troubleshoot as you go along. So I encountered a problem with when I had this over here, and so I had it outside. So when you encounter these kind of problems, maybe think about the order and if you of where your code is. So this is just one way to think through your code. So I'm going to do it again. Has everyone able to actually do and play it against themselves? Yes. And I keep winning. Social distance. Yes. So one of the things here, 1, 2, 3, and I beat it. 1, 2, 3, and I beat it again. Did I press it the right time? 1, 2, 3. Tie. So, so this is just one way to actually learning to code with your students, is to actually try and walk through it with them. Another way that I've seen very successful when students are learning to code is actually to give them a code that is broken. So let's say I had given you this, but let's say I had put in, instead of putting the full code in, I maybe input a number, show a number here. And then, did something like this. So taking out something and saying, hey, something's not working. How do we get this to work? So that's another way that you could have students learn how to code, especially right at the beginning. And you can also talk about probabilities. So this can lead into a math lesson as well, because you could actually talk about what is the probability of selecting scissors out of 10 times, right? And you can talk about the math that goes with that, but also you can then execute it and see what the results are. And then you can talk about, is 10 times enough to test it? How many times do you need to test something to test the probability? So just one way of sort of integrating a new learning code, but also talking about a concept in math. And that's just one way. We have several different ways. Any questions as you were going along, or any questions about these? We only started with the very basics here. Andrew, if you want to share anything that you, not to put you on the spot, but I know that you were mentioning, this is great, okay. You were mentioning that you teach this often. Is there a strategy you use when you do an introductory lesson in something like MakeCode or Scratch?
No, it's always good to, demonstrate some of the blocks that are there and the different categories. Yeah, and then maybe building something with them just to get experience with it, and then, all right, go to it, and then it goes wild. Yeah.
Yes. The other thing I like to do is I sometimes do it where I make a mistake, or I'm very open to making a mistake. I think that's an important part about learning to code, and actually making in general when you're doing hands-on learning. So it's things such as, if I'm doing a code, making a mistake and being like, I'm not sure how to fix this. How do we fix this? And working together on ways that you can actually fix or learn how to code something. So being open to that is really important. I do think trying to get some sort of basic understanding of the codes is good as an educator, to be able to know what some of them mean. But you can learn together in terms of creating a game in this particular example. I like to do this mode versus just telling them to do a tutorial, which is basically they're looking at it, but they don't always know necessarily why. So this way you can maybe talk through why you need to do certain pieces of code. But some students are very visual. Some students need to learn on their own. So having different options for them is really important. So one of the things I mentioned is that there is a compass option. So the one we have created, I mentioned we've created an irrigation system, so like kind of a smart plant. We used external sensors, such as touch sensor and moisture sensor. So there's a lot of them that are different options, but one of the onboard sensor is the fact that the compass heading. And so your microbit can actually function like a compass. So I am going to ask Jen if perhaps I'm going to stop sharing. And are you okay to share, or how do you want to show them the...
No, I will share. Just give me 1 second. I'm just downloading the code onto my microbit. I was playing rock, paper, scissors with myself. So give me a hot second.
Yeah. So Jen has a microbit on site. What we really did want to show you is actually what the microbit looks like. And one of the great things that is the compass feature. One thing I will mention about the compass feature, unlike other codes, and maybe Jen, when you do it, you can just talk a bit about how you uploaded. Because the one thing is we're just creating code, but the second thing is you can see this big download button. You really have to put that code into your microbit. And then you have it on your microbit, and you can add the battery. I'll stop sharing here. But yeah, so we wanted to show you the compass because it's a kind of interesting feature of the microbit. But also, it's one of those ones that's slightly different. A lot of times when you upload your code from MakeCode to microbit, the code will go directly into your microbit and it's ready to go. But with a compass, you usually have to set it up, right, Jen? There's some sort of it's like a sensing thing. You have to do a little bit of I forget what the word is, but it's almost like setting it. Yeah.
So the microbit has, in addition to the sensors we talked about already on it, it has what's called a magnetometer. I have no idea if I'm pronouncing that correctly. But effectively what it does is it works based on magnetism, and it detects changes in the magnetic field. However, if you think about if you've ever played, say, yeah, exactly, you have to calibrate it. So if you've ever played a game on your phone that maybe involves some sort of motion, like I'll nerd myself out here. So Pokemon Go relies on your phone's similar capabilities. But sometimes what will happen is it won't be detecting properly where you are, so you have to reset the program. I'm sure you've had this before, even with your computer. It's acting funny, so you reset it. That is something you do have to do with the microbit. And the magnetometer chip on it is you have to calibrate it. So I'm going to share my screen, which has my code up now, since I've had a chance to go through and put it onto the physical microbit. Just wait for that to load here. Now, I will say that I sort of tweaked it a little bit. So underneath the tutorials that microbit has built in, there is one to walk you through how to build this compass code. But as Marky knows, I don't necessarily like stock code, so I tend to change stuff to like suit my own purposes. So you'll see that shortly. But just to show you what this code looks like, and I'm gonna see here, it kind of takes up the whole screen, so I can't really zoom in too much here. But I've got a bunch of different things set up here. This on the left under the forever, that's the code that the tutorial walks you through building. So it has basically, to walk you through this, for the entire time that your microbit is on and functioning, It's setting up a variable. So we've set up a variable called degrees, and we've used the microbits onboard compass heading, which uses that magnetometer chip that I talked about. So it's detecting that compass heading and setting that value to that variable. And then like we just did with the rock, paper, scissors, I've gone through and put in an if, and else statement. So there's a bunch of things here that we can unpack, and we will in a second. But just to kind of walk through what it's doing, it's saying that for each of our 4 cardinal directions, if the degrees that it's reading from the compass heading sensor are within a particular bounds, it's telling the microbit to show an arrow corresponding with that. Now, I'm curious for those of you looking at the code and thinking, okay, so we know degrees, there's 360 degrees in a circle. Why are we using 45 and 135 and 225 and 315? If anyone has any ideas, feel free to pop it in there. Because I really liked this, that there's some math involved here and some geographical reasoning. Double question marks. Yeah, I like it. So the way this program is, or the way we kind of make this work, yeah, you could do that. So if you're thinking about, I want to show north. So with this first bit here where it's showing north, north is effectively 0 on our compass reading in this microbit program. But it's not 0 to 90 degrees, right? If we think of it as a circle, because that would encompass north, northeast, and east. So what we're doing is instead of having 0 to 90 degrees, we're shifting our circle a little bit. Pardon my arms. Hopefully that kind of illuminates it. So we have from 0 to 45 degrees is north. But if you walk through the code a little bit here, 315 to 360 is also considered north. So we've had to shift our circle a little bit. If that doesn't make total sense to you right now, that is totally okay, because you kind of need some time. And I think Margie might be holding up a picture of what she's drawn here. I have the chat open. Yeah, exactly. So if we had done 0 to 90 degrees, it would have taken us all the way fully to east. And then east would be reading, 90 to 180. It's something you can work through with your students. It's not imperative that you understand that right now, but that's something that I thought was interesting when I was working through this code, is that you do have to think a little bit about how the degrees in a circle work and how we might change that to work with the compass.
If you can see Margie's cam there. I don't know if you've ever seen those makeup tutorials. I'm always trying to replicate them. And yeah, how do you see it? Sorry. But basically it's a circle and you can see the degrees at the top. But yeah.
Yeah. So like Andrew mentioned in the chat, this code has a calibration built into it, and it will actually do it automatically. Anytime you are asking it to use the compass heading, the first time I take my microbit here and plug the battery pack in, it's going to come up with some text across it there. And what it's going to say, and I think it's backwards. It's backwards for me. I'm not sure if it is for you. But it's
forward for us. It's good.
Oh, good. Good. Yeah. So what it's saying is it says tilt to fill the screen. And then it comes up with some dots. Now, I don't know how well I can do this on camera, but basically what you need to do is physically tilt your microbit around. And it's kind of like those old school games where you're trying to get the ball. Some of you might be too young to remember this, but you're trying to get the ball into like a little hoop in a water thing. You basically need to tilt it until you're filling your entire screen up. This isn't particularly visually appealing, but I've managed to fill my screen. So it pops up with that, and that gives me a little smiley face. It's like, yay, we're tilted, we're calibrated. So you can see that it's giving me arrows. Right now it's a little funky. Typically when you use a compass, you would think you're going to turn your entire body to show the compass, and the microbit does work that way as well. But because it's using the magnetometer and it's working on tilting, I should be able to sort of tilt it. So if I tilt it backwards, the sensor is down, which if you look at the code, it says that within a certain degrees, that's characterized as west. If I tilt it forwards, it should be reading up for north. If I tilt it to a side, yeah, it switches to east, I believe. I'm trying to read this backwards. And then if I tilt to the other side, the arrow switches. Now, I've gone ahead and overcomplicated this because, like I said, I typically hate standard code. And when I was working with this as a compass, it was driving me insane because I still had to use my brain to figure out what the arrows meant. So I didn't find it particularly helpful. So I added another one on here. if you can see here, on button A pressed, show me the direction as a letter. For me, that's easier to interpret. So it's going to show me an arrow. So I'm tilting it forward. And if I press A, it's giving me the N. So if I tilt it backwards to show me south, I can press the A and it shows me S. If I tilt it to the side to hopefully show me one of the other ones. Oh, that was north again. Come on. Sorry, the tilt is really hard on camera. But you can kind of see the arrows switching. And then, yeah, I've pressed A and it's giving me the letter. For me, that was easier to interpret. But what you could do is have students go through that initial tutorial and see if there's anything, again, like Margie was saying, that they think is wrong with it, that they think they could customize to make it better. If there's any usability issues that maybe they saw with it. Because for me, the arrows drove me absolutely insane. So I took the code and I fixed it to make it what I thought would work best. Yeah, I think that's all the notes I have for that. It's a very complicated code. Margie, were you wanting them to attempt to recreate this, or did you just want to show it? Yeah, your mic's off. I see you were shaking your head no, though, for no, you just wanted to show it. But that is one kind of possibility of what you could do and take the same sort of coding that we just did with the rock, paper, scissors with those if-then statements that some people find difficult to kind of understand and make it a little bit more complicated, a little bit more high ceiling. So we're bumping that high ceiling up. You've learned how to use the if statement. Here's something else you can do with it and utilizing some of the other onboard sensors.
And they could even step it up even more if they wanted to learn the JavaScript. So if you clicked on the JavaScript here, Jen, they would actually be able to see this code in Java. So it's a way to help them start to learn Java. The reason, one of the things I like about this is not just the math, and you're also talking, you know, because you got to think about the degrees, but it's also what I like to do from a language perspective is for my son, I'll give an example. He's not a great writer, and he's told to write all these stories right now, and I'll write a letter to me about how you feel about COVID-19. And, you know, my son, he's grade 5, and a lot of his friends are the same way. They don't like to write about it. So what I encourage him to do is to actually write tutorials. He can start by doing, because he loves tech, he loves coding, those kind of things. And so I actually encourage him to first create a video to help him learn how to communicate, and second, start to write. So ideas. So now we're getting into literacy. We're getting into abilities, even with Microbit, on how to actually, and it's helping those students that may not be able to write just the standard letter, just go ahead and start writing like that. But he can easily start writing about how to do a code, or, for example, to create a compass on a microbit. So think about options in your lessons, I think, in incorporating things like technology like this. It can work in terms of different types of subjects. And I also mentioned even about the moisture sensor. So I'm just going to go back here for a second, and I'm going to start. Can I take this screen? Is that all right, Jen?
Give me one sec. I'm going to relinquish it.
Yeah, Andrew mentioned the Northeast, the Southeast, etc. So now you're talking about not just geography, but also science. But you can also expand into some of these by looking at, I'm going to pull my screen, but looking at your code. So looking at some of the things you're doing, and for example, the moisture sensor, there's an activity there. The moisture sensor, you can actually buy one, or you can create one. So you can talk about it with your students when you're maybe in physics class or in biology class, because you're now talking about conductivity. So you can talk about the ideas like, I have this, I want to measure the moisture in the soil. So I need to have a conductive circuit that's going through. What kind of materials would we provide, et cetera, et cetera. So it's just different ways of looking at some activities that can be engaging and thought-provoking. Let me go in here. I'm going to present now because I want to come back and go to the screen. So one thing is we've gone through the MakeCode right now, And we've talked about, going through some strategies in terms of how you would teach code for the first time. But there's some other things that I wanted to mention about coding. And this is just from experience that we've had, because we've done a lot of projects and gone to a lot of different schools, worked with a lot of students, but also teachers. And one of the things that's really important as you get into more code or different projects is to really establish that culture of trust and risk-taking. And what does that mean? Well, it means that students are okay to share or to ask questions, knowing that they may not be the experts in the class. So you really have to have that, because sometimes if you don't have that, then you're just going to have the ones that know how to code speaking. So you really want to sort of work on establishing that environment that allows all students to feel comfortable in sharing, even if they're beginners. Tribes in the classroom. Yeah, I'm starting to, that idea of that classroom culture. And that actually talk about that. Tribes talks about creating classroom agreements. Well, just to build on that, the classroom agreements, I actually, like in teaching coding specifically, one of the things you will encounter from students is, I can't do this, or it doesn't work, does not work. So I always like to, no put downs. I always like to say, we need to fail. So I want mistakes, or something along the lines, like something that says mistakes are so important. Let's make mistakes. I actually sometimes teach lessons just by mistakes and let the students fix my mistakes, because I feel that appreciating that the power of making mistakes and what you can learn from it is really important for students. It helps them in their own growth mindset. It helps them in their perseverance, etc. Just some of the others, mistakes are welcomed here. That's great. As I've learned that mistake making is the funnest part. Exactly. So anyways, that's one of the ones there. And then these are just some of the others. You'll have this presentation, but some things to keep in mind. One of the things I always say as a teacher is, sometimes I say, even if I know it, I say I don't know. Let's look and let's figure it out together, or let's all of us talk about it together in this group. Or has this group over there discovered it, this group over there? Maybe we can share some ideas. The other thing that can be important sometimes is just taking a break. If anyone has coded a lot and come in, I've been through that experience of going through a project, trying to get it done, and it's just not working. I feel like I'm not making it through. And sometimes just walking away for a minute, looking at something else, taking that break is really required. So these are just some of the strategies. Does anyone have any other strategies? I like Katina's mistakes are welcomed here. No put downs, absolutely. Yeah. Okay, so I'm going to go on the role of the teacher. So what is the role of the teacher in when you're coding? To me, it really, there is a bit, you saw at the beginning, I did some guided instruction. There was a little bit of direct instruction even. I do think we call that sort of structured inquiry. You're still discovering a little bit, but it's a little bit more guided. That can happen at the beginning. There's other ways. You can start by just doing some free inquiry, but the role of the teacher does tend to change a little bit from always being the expert and the person that has all the knowledge and telling you some information to being someone who is learning alongside you. More of a, I hate to say this, but a facilitator, a guide. And I think it's also important that you're transparent with your students. I talked about this, I'm not sure it was with you, Nadia, but I did talk about it with several of the interns that I worked with, is I open up with the students, say, you know what, I'm not the expert in coding, but these are really engaging activities and fun things to do. And so let's learn together. Yeah, so it's really that learning journey together. But I will say there is that point where frustration can become a disabler. So it's recognizing the signs when students are becoming too frustrated and knowing when to be able to go in. That becomes very difficult in an online learning environment. So having that conversation beforehand to let the students know, hey, if you're getting really frustrated, let me know, hands up, and we will try to work through this. So trying to find that just-in-time learning. Any thoughts on this, the teacher's role? Learning together. So I did see some comments there, and I think we talked about a few of those, getting uncomfortable, learning together, the teacher's role changes. I really want to talk about, we've gone through some activities. On the following pages, there are activities. We're not going to go through them in depthly, but I did want to talk about, and also I showed you that microbit and the microbit lessons. So one thing is, I didn't think I would fill this presentation full of activities that Microbit already has on their website. They have so many activities. As I mentioned, it went to every grade 7. So all of those, so many of those lessons are actually posted there, and other websites they have links to. So there's just so many resources for you to try. But my question to you, and I'm hoping people can come on the mic, is there any ideas that sort of come to mind? Anything that comes out that makes you think about, thanks, Katina, appreciate it. Anything that comes out that makes you you think about an activity that you can do with MakeCode and Microbit, and any challenges. So any of these questions here.
Hi, Margie.
Hi.
Hi, it's Nadia.
Hi, Nadia.
So, I know we've already done the microbit, like I did it in my class and everything, but we made some unplugged activities too that it could be incorporated just to get the kids kind of started. And of course, one of the things that we did with our class was the greenhouse activity, even the piano composition. So these are some of the things in the candy machine, which some of our class fellows really liked a lot. So there are a lot of, sorry.
Oh, I just said cool. The greenhouse, what was that? Can you tell me a little bit?
This is what we did with our cohorts, not the students.
Mm-hmm.
So the greenhouse activity was the same as what you said, making and testing the soil moisture sensor, whether to see whether the soil was moist or not. The only problem we had, because of the time, we had a very short amount of time, so we kind of gave them the code. But even still, it was challenging for some of them to kind of put the code together, because some of the colors, the corresponding colors did not match. And that's something, like, I don't know, when in future, if you kind of do give your class, like if you give them the code just to get them started, to get them comfortable with using the different codes, it's to tell them that sometimes the colors don't match properly. And that's something you told me also, because you can get frustrated thinking that the purple is what is it, a logic or whatever, and it's not that. The blue is, the colors don't match. But there's so many awesome things that you could do. It's just that you have to have a lot of time to kind of practice it and get comfortable with using microbits.
Yeah.
Yeah.
Thanks, Nadia. Yeah. So one example Nadia and I were talking about is when we were first going through the instruction, I actually had a printout of code. So I had gone to a workshop, and there was people very quickly looking at the code. So I knew that they wouldn't have a lot of time to actually go through it, but I wanted them to try some of the sensors. So I gave them the code in a printout as a resource. The problem, as Nadia said, is sometimes you got to watch your printer. So some of the colors didn't match directly to the colors that were on the screen. So it caused a little, some people can get confused. It's like, wait, that's not purple, it's pink, and it doesn't appear right. So, that's that just-in-time support that may be required, and just be aware of those kind of supports that you have. Jennifer mentioned this, I'd love to incorporate more traditional visual arts projects with coding technologies. Yeah, I mean, personally, I haven't done it in Microbit, but there in Scratch, I've done motion geometry, which can turn into lots of really pretty images. They're that look like artwork. And it's all from code. So there's a really nice relationship between code and art, visual arts. I'm not an expert in that area, but definitely I've seen some really amazing things. Sound recordings, absolutely. I think the music option, I've heard various different people talking about the music options as being a great thing that they've actually incorporated in their music classes. So I'm going to continue here I'm not going to go in-depthly into these slides, but this was very beginner activities that I wanted to put in first. Like I was thinking about my daughter here. So I'm thinking about, really primary or very beginners first time. But I mean, I was thinking about for primary age, like how great would it be to see the sun shining? Or like in my son's class, they're saying, what zone are you in today, which is your emotional zone. So you could show it in Microbit, right? You could code it in Microbit. You could code your own image in Microbit and actually have it change. So put the pause in and change it, and so like animate it a bit. Maybe you're both happy and sad, so those kind of things. A mood ring, yeah. Creating a name tag, so a great beginner activity. I always say first week of school, great time to start discovering with coding, like free inquiry, because a lot of students are getting to know each other. You can establish custom agreements and at the same time have that time to start discovering coding. But creating a name tag, detective games like whodunit. So that was one of the things that we were going to do in camp, is sort of have this using the radio transmission to try and pair people up. So that was the idea I was going to do, but you don't know who your pair is, or you don't know who has the similar code until you go around and you check with using the radio communication. So everybody's given a secret code and they have to find out who's the same one. Yeah. So Andrew, yeah, that's, I mean, when I kind of really love that radio functionality, you could almost do a fun whodunit, find the clues and find I hate to say murderer, but find the person who did it, that convicted the crime. So lots of different ideas there, but these are just some ideas. The one on the left I wanted to show here is this. This is a really interesting lesson, and I think I put the link in here. So if you click on it, but it is a Microbit challenge that went out. It's 90 minutes. It integrates with language arts, social studies, and technologies. And they actually encouraged it to submit the pieces. So there's lots of examples here. And I thought this was a really, really great project. It goes into linking up to the UN's global, I'm going to say it wrong, but their UN has these list of, yeah, is it SDGs? What are they called? What's the actual word for them, Andrew?
It's the UN Sustainable Development Goals.
That's it. Yes, thank you. And so this one links, thank you, Jen. This one links directly into that. And there's this whole part, and then it incorporates Microbit. So really excellent, fun, not so much a beginner, but definitely an option there. And the whole website, actually, there's lots of different options. So if you want to click on that. Two things that can take it more. We talked about using it like a makey. So, using it as a conductive. Because remember, if you start using the pins, you can actually start creating a circuit. So you can then incorporate things like oranges, bananas, even your graphite in your pencil. So if you do a drawing, that can be, you can do touch, that's all conductive. People holding hands, all of those things are conductive. So you can actually create a circuit and even use your microbit. You need, you could use your fingers on there, but I would use alligator clips. And if you're using fruit, you can use the alligator clips. So in this case, if you'd have to watch it, but basically it's playing an orange, I think, or it's tapping on an orange, and there's a code that will be displayed. You could have, you know, this is, you'd have to, if you were touching a microphone or a sound of some kind, that's, I think it would be a speaker or some sort of instrument. It would be attached with the pins. And yeah, that's the next one where this one actually has headsets. So it's actually, it's speaking out into the headset. So you can watch the code on there. So that's 2 ideas for integrating music. And this, to me, this is science, but because it's a little bit with the orange, it's talking about conductive materials, et cetera, like, et cetera. Not to take it to, but when you do talk about circuits, I like to do this. I measure ohms law. Now, in this video, they don't actually use a microbit, but you could replace it with a microbit. When you are creating a circuit and you're lighting an LED, for example, a lot of times you have to have a resistor on that circuit. You don't want to overload an LED or some sort of other output on the circuit because too much current coming in can burn it out. And so you usually need resistors, and that's where we go into Ohm's law. So in grade 9 in science, we start talking about that. And so this is just an example, but it's the idea that in microbit, that attachment, you can start figuring out and doing measurements with your multimeter and figuring out the current, you know, the voltage from either your microbit, which would be 3 volts, or if you use it in some sort of, what is that thing called, Jen, the Inksmith, the not the breadboard, but the...
Weirdly enough, I think they call it a breakout board.
Breakout board. The breakout board, I don't know why I can't remember that one, but breakout board, it actually is something that the microbit plugs into and it gives it power. So you have more voltage in that, or edge connector, yeah. So in those cases, you definitely need to start thinking about resistors. So it's really important to, so those are a good way to teach this and expand it into sort of your upper levels. In grade 6, you talk about circuits. So you don't go into Ohm's law, but you can definitely start dealing with circuits, adding on to that microbit. So just continuing on, mentioned the InSpink. Okay, these 2 are just links for you, which are the InSpink Climate Action Kit and K8. So robots that link up here with the microbit, and the Climate Action Kit, lessons, activities, how you do it, how you set it up, and you can see the plant there with the moisture sensor, but there's great activities here, so I can't recommend this enough. So pretty much that is the activities I had, and primarily it's because the link that you have to the microbit lesson is immense. Once you start going in there and start clicking on it, you'll start seeing how many lessons and activities and options there are for educators. So I do encourage you to explore those and that link. And this presentation is available to you. I just want to finish with some final thoughts or any questions that you have. We call it the rose, thorn, and bud. And hopefully, if you click on that Padlet, it should work. But Jen has shared it. Thank you, Jen, in the comments. And if you want to hop on the mic or just go to the Padlet, I'm going to open up the Padlet and just ask if you can put in a row something you learned, a thorn, a challenge, anything you're looking forward to. So this is really important. This has been a smaller class for us in a lot of our online, but if there is something that you'd like to explore more, even if it's the tips and tricks in online learning, put it in here, because we could definitely collect those and try and determine from people what they're most interested in terms of follow-up sessions as well. Yeah, so, or if you just have a comment, feedback, something specific you think we could work on for online learning. I will say this has sort of been my second time leading, and I think it's the third time being in a session. Online learning is as you start to discover, it's its own it's quite unique to being in class. So there's lots of things that you have to keep in mind. I'd always apologize. I'm looking this way because I'm looking at the comments, and my screen is here. I always keep 2 monitors on, so it's one of those things. Yes, thinking about running a webinar in the future. Yeah. Webinars are great. But they also have the limitations in terms of not being able to, well, I guess you can answer the questions as long. What was it that we were saying about webinars, Jen? What was our challenge with them?
Just for us, and this is definitely just a for us thing, but in the lab, we tend to do, like Margie mentioned earlier, a lot of structured inquiry. And for us, that means being able to do hands-on stuff. So were this session bigger, what it would have looked like is we would have split up into 2 or 3 breakout rooms, and then we would have had a small intimate group to actually do some hands-on stuff, go through together, share your screen, etc. I love webinars personally. I'm a big passive learner. But for some people, especially if you're working with younger students or what have you, it can be useful to do that synchronously so that they can share their screen and share feedback in real time. Webinars are also great, though. And unless I'm interpreting that incorrectly, so a lot of times the term webinar is used as kind of a something like maybe you would use a streaming platform and you would stream, but you wouldn't necessarily have as much engagement with the people attending. So there's a couple different ways to do these sorts of sessions, and webinars are one, interactive sessions are another. They've all got their pros and cons for sure.
Thanks, Jen. So thank you, everyone. I hope you were able to get what you wanted out of this session. If you have any further questions, please use this. I usually monitor these Padlets for around a week or so afterwards, just to answer anything. So keep the link. You have the slides. Don't forget the bit.ly. I would save them and make sure that you have this as a resource, lots of links in there. And I do appreciate all of you. Thank you, and good luck in your future. I think there's a few Ontario Tech University 3rd semester students here, so good luck in that online learning semester, and also thank you to the others, and good luck in any future webinars or teaching that you're doing.